Well, good afternoon, everyone. I hope everybody's having a great Thursday. Just think this time next week we'll all be loosening our belts and getting up from the Thanksgiving Day table, and we'll all be having having to get out and get a little walking in to try to get all the food to settle it down in your stomach. I wanted to thank everybody for coming. I see that we have 5 people in today. Today, we're going to talk about oven repair. Okay. We're going to talk about more in a generalized, if I can work on an oven, I can work on an oven is basically what I'm trying to tell you. You know, on a Whirlpool oven, it's not that different from a Samsung oven or an LG or a GE or a Viking or a Wolf. They all work off the same principles. Okay. The first things that I've got to know as a technician is how to read a wiring schematic. Okay. We're going to delve into reading a wiring schematic. We have a course before the end of the year, and it's called Wiring Schematics 2. This is the second install of reading wiring schematics. So this is a portion of that wiring schematic class that will be happening in December. I just wanted to let everybody let you know that that's what we're going through right now. Hang on just a second. I'm trying to get through everything else. If somebody has a question, on the very bottom right-hand side of the thing, there is a post a comment box. Go ahead and type in the comment, and I will get back to it. Whenever we go through this, we're gonna stop if once I get into it, because we get into some issues, and I just want to make sure that everybody understands it and that everybody is comfortable with moving on. There's nothing worse than being lost in a class and not understanding what was being asked or being said, and you just get more and more lost, and it doesn't do you any good. This class is given to you free of charge, and I'm gonna plug Encompass right now. Okay, this is all part of Encompass University. Thank you very much, Encompass. We really appreciate you providing this at no charge to all of our service technicians and probably some DIYers out there. So let's go ahead and get started with what we've got here. Okay, so our agenda. What is contained in a wiring diagram? Maybe what I want to look at is what should I check, some common failures with the board, and what to look for. Okay? Because if I walk in and the oven is dead, I probably have I have either a power issue to the oven, or I could have a blown high limit thermostat. Okay, so as we're getting started here, let's talk about reading a wiring schematic. Okay, after this program, you should have the basic knowledge to read and understand a basic wiring schematic. Okay, also you may find that I refer to them as a wiring diagram. Exactly the same thing. A schematic and a diagram are the same things. Okay, so the first thing we're going to talk about is power sources. Okay. Basically, there are four basic power sources. Okay, every circuit uses a power source. It has to have a power source. If it doesn't have a power source, it doesn't operate. Okay, it's important to know and understand how the circuit is powered, and if it's AC or if it's DC, or it could be a battery. The most common symbols are listed on the right side here. For 120 volts, you can see that the plug there for 120 volts. I have line voltage, I have neutral, and on anything that was made after 1969 or 1970, it may have been, it has a ground for that plug. Okay. On the other side is a 240 volt circuit. Okay. If it was made before 1980, it will have 3 wires. Okay. It will have line 1, a neutral, and line 2. If it is made after 1980, it has 4 wires. Okay. That is line 1, neutral, ground, and line 2. Okay. A DC power source. We're going to get down into DC power source a whole lot farther down. One of the things that you're going to come to understand is, how a DC power source powers. And as you can see here, the power source is just a plus and a minus symbol that's there. Okay. Then we have the batteries, and even excuse me, even though we have many different kinds of powers, one of the battery powers, a perfect example is like my computer has a battery tied into it so that I can go around and I can work without having to have it plugged into a power source. But still, that's a power source, is a battery. Okay, so power sources in more detail. I wanted you to take a look at our battery that we had just talked about. Okay, on a battery, the longer lines, okay, mean that it's positive. Okay, most of the time there is a plus symbol right there where that's if you look at the symbol itself. It shows you that there's a positive symbol, and that tells me which is positive and which is negative. Okay, the shorter lines are your negative lines. Okay, so once we go through this, there may also be a positive symbol to help identify the battery. I just wanted to make sure that I caught everything that I had said in there. But we're going to go a little farther into batteries. Okay. So here's our AC current. As I said that, currently there's 120 and 240 volts. Then we have DC power sources. And then if you look right there, you see that there's a ground symbol. If you look at the 240 volt symbol, you can look right there in the very center next to the neutral or just below the neutral tab, and there's a ground. You can also look at your 120 volt, and you can see that there's also a neutral there that goes to ground. So grounding has become a very important part of our power sources. Okay. One of the things that we need to talk about though is an earth ground. What exactly is an earth ground? By definition, an earth ground is exactly what it says. Okay, it's a ground that is driven down into the ground, and then it has a wire that is attached to that ground that grounds everything into the earth. Okay. I just put in a meter box for a trailer, and the trailer, I had to put the meter box in, and I had to drive in an 8-foot earth ground, and so it literally you have to drive that into the ground. There are 3 types of earth grounds currently. Okay, there is a copper. That copper weighs about 18 to 23 pounds, depends. And there's also an aluminum and then an aluminum oxide ground, earth ground. Okay, all of those have to be 8 feet long. It's like I said, it's driven down into the ground, and then that's where we get the earth ground on one of our on our 4-prong plugs, or if it's a 3-prong, it's an earth ground to the plug on the 120 side. Okay, this is a picture of an actual earth ground. Okay, as you can tell right here, there's a call out box and a little arrow that shows you the wire that goes down to the earth ground. It's a little difficult to see the actual where the rod that's been driven down into the ground for the pole. If you notice, this is somebody's home right there is behind it. This is they have to run a wire, a 4-wire run out to the box from the house back to the power pole, and that's where the earth ground is tied in. Okay, so once again, this is the 3rd prong that's connected to the earth ground. So my home in Daytona Beach, actually, until I replaced several of the plugs, I only had the first 2 slots there. Okay, so I had a neutral and a power line. I didn't have this earth ground that's on the bottom. I do not have an earth ground that is driven into the ground at my home in Daytona because it's so old. That actually, my home in Daytona was actually built in the 40s, so it didn't have any of these. Okay, so let's talk about some of the connections and terminals that we're going to have to look at. If I'm a technician and I'm looking at a wiring schematic, and I'm trying to figure out, does it go through? Does it stop? Is it a continuation? So let's talk about connections and terminals. Okay, understanding terminals and connections. Terminals are connected, or a connection point to an external circuit. And one of the things that you need to note is that they're represented by just a circle. They're not filled in. It's an open circle. If I'm looking at a terminal connection, it's the connection. It's the difference between the connection point, okay, and the terminal connection. Okay, terminals connected are different, and they noted as solid circles. So if you can look right here and see the difference. I'm going to show you some real world examples here in just a few minutes, whenever we get a little bit farther on down the road. Oops, I'm sorry, I told you wrong. I thought that I had one more slide in here, but I was wrong. So if you look right there, that's a terminal connection. Okay, and then the one that's open is just the terminal. Okay. Now let's talk about switches. There are 2 main types of switches, okay? There is an SPST. That stands for single pole, single throw switch. This is basically an on-off switch, and it gets it shows up in the wiring schematic right there, okay? Just like that one. So the one on the very top shows that that it's open right now. So I haven't depressed the switch that causes it to close. Or if I have something else that causes it to close, it's not. This is still showing that it's open. Okay. The one on the bottom is actually closed. Okay. The top switch shows that the circuit is in the open position, and the bottom is showing that it's in the closed position. Okay. The other thing is the single pole double throw switch. Okay. That is an SPDT. Okay. That can be a direct power to the circuit parts, or the route in the power is determined by the position of the switch. Okay, so a good example of that is a switch in your microwave. Whenever I open my door to my microwave, I have a single pole, single throw switch. Whenever I close that door, the switch is closed because there are levers in the microwave itself. Whenever I close that door, it pushes against the switch, and that closes the switch. Same thing. Another example of that is a door switch in an oven. Okay, those are your single pole and double throw switches. Okay, so we have a momentary switch. The momentary switch is actually your push to start switch in a dryer. Okay, so that's a momentary. They only remain open or closed while the circuit is being pressed. Okay, the common type of switch are push button style. The top diagram shows that the switch is in the normally closed position, and the bottom is it's normally open. So what would happen is it would be in the bottom cycle. Whenever I push my push to start switch on my dryer, it closes that switch. That switch actually remains closed because there's current that flows through it. Once I lose the current that flows through that switch, it will open up. Okay. The switches have two inputs. This is a single pole double throw. There are two switches in here. A lot of the times the switches are married together. And like if you look at your microwave, there are two switches that are married together in the microwave itself. Some of them are normally open. Some are normally closed. That's what you need to know. And you need to know whenever you're looking at them, is that switch open or closed by me depressing it? Okay. So a single pole double throw. Here's a perfect example of this single pole double throw switch that we have right here. Okay. These switches have two terminals for the input. Okay. And four terminals for the output. Once again, it's a double pole double throw. That's all it means by that. This allows you to switch the path of two currents simultaneously. Okay. And the schematic symbol for a double pole double throw switch is the one that's exactly right there on the right. Okay. I apologize that is I had it in white, and for some reason it went crazy and it decided that whenever it transferred over, it didn't want to transfer over in the white. Okay, so here's some samples of switches in a circuit. Okay, if you look right there, that's a single pole, single throw switch at the very top. Okay, there's three of them in line. I have a push to start switch. Okay, those are right there on the right side. We're going to get down and we're going to look at we're going to get more in depth, and we're going to keep moving along, and we'll get to it. Okay. Before we get to the resistors, I want to stop for just a minute. Okay. Does anybody have any questions about what we've gone over so far? I will tell you that I am not the smartest cookie, and I ain't the sharpest knife in the drawer. But if you've got any questions, now's the time to ask them. I do not have I have an electronics background, but not. I didn't actually graduate college with an electronics background. Okay, go ahead and ask any questions that you have. Okay. Doesn't look like we have any questions. Please, if you have a question, please ask it. That way we can answer it now instead of going way back and finding it. Excuse me. Okay. Resistors. A resistor provides a power to a circuit. In the U.S., the resistor on the left is the symbol. Okay, if it is the symbol on the right is the international symbol. Okay, you may see the symbol on the right more frequently due to all of the imports that we've had. One of the things is, if you're looking at a Samsung oven or some Samsung product, you're probably going to see the symbol on the right. Any foreign manufacturer, if they bring it over, we're not on the metric system. As you well see today, there's a whole lot more of metric system items that are coming to us. As a matter of fact, I ordered some bolts and some nuts and some washers, and they were all metric. And I had to have metric tools to be able to work on them. Okay, so we're slowly getting into the world international symbols. So just as we go on, you're probably right now, me being an old technician, I am a whole lot more used to the one that's on the right as opposed to the one that's on the left. Okay, that's a regular resistor, the one that we have just talked about. Okay, a variable resistor. Okay, it can increase or decrease power depending on the external output. A thermistor and a photosensor are examples of a resistor dependent on temperature or light. Okay, so if you look at the examples below, that's what it looks like. Once again, the one on the left is the American. The one on the right is international. Okay, if I'm going to be reading color codes, let's say that I'm with looking at a Whirlpool oven, and I go to the board and I need to know what resistor, what the lines mean on the resistor. So I have to know how to read the color codes. Okay, resistors usually have 3 to 6 bands that indicate their resistance, their tolerance, and sometimes their temperature coefficient of resistance, which is labeled TCR. Okay, this will be on your wiring schematic. So if you see TCR beside that, that's telling me that that's a temperature coefficient of resistance. Okay, so the bands are read from left to right. The reading's direction is not always clear. To distinguish the reading direction, the tolerance band width is sometimes printed. Usually it's a 1.5, sometimes it's 2 width of the regular bands. But that tells me right there that that's the way that I'm supposed to be reading it. If something happens and instead of it being read from left to right, it's read from right to left, my band on the right is going to be a wider band. Okay, a larger gap between the width between the tolerance band and the other bands is usually noticeable. Okay, if a gold or silver band is present, then they must be at the right side, since they're never used for significant digits. It is always better to check the manufacturer's documentation or use a multimeter to get the exact resistance value. I would tell you that if I'm going to check something, that's how I'm going to check it, is I'm going to look at the resistance values, and I'm going to add those up, and I know exactly what that resistor should be putting out. Okay. In a 3-band resistor, the first 2 bands represent the first 2 significant digits, followed by 1 band for the multiplier. Since no tolerance band is available, the tolerance will always be plus or minus 20%. So if I only have 3 bands on my resistor, it's telling me that I have a tolerance of plus or minus 20%. In a 4-band resistor, that's the most common. The first 2 bands represent the first 2 significant digits. The 3rd band represents the multiplier. The 4th band represents the tolerance. Okay, so if I've got a 4-band resistor, the first 2 are the significant digits. The 3rd band represents the multiplier, and then the 4th band tells me the tolerance that I have, the plus or minus value. In a 5-band resistor, the first 3 bands represent the first 3 significant digits. The 4th band represents the multiplier, and the 5th band represents the tolerance. In a 6-band resistor, the first 5 bands, okay, have the resistance same as the 5-band resistor, followed by the 6th band, which represents the temperature coefficient, or the TCR. Okay, resistance coloring. That's the way that you know how to read a resistor. Okay, color coding is the method used to indicate the resistance value, tolerance, and temperature coefficient of resistors with low wattage ratings because of their small size. Color and bands are used because they can easily be read and cheaply printed on a small electrical component. Color coding is also used for capacitors and inductors and diodes. Okay, so all of that information just told you about the color coding, both for capacitors, inductors, diodes, and resistors. Okay, the resistor body surface is large enough, like in a large wattage resistor, the resistance value, tolerance, and wattage is usually printed on the resistor. Surface mounted resistors use another coding system that uses alpha numeric codes printing on the surface of the color codes. Okay, the coding is defined in the international international standard, which is IEC 60062 2016. It is described the coding standard for both capacitors and resistors. Most of the things that we look at as an appliance technician with resistors, I'm either going to get a 3, 4, 5, or a 6-band resistor. Okay, whenever I tell you what I'm looking at right now, okay, so this tells me that this right here, okay, I have a brown band, which tells me 1. My next band is black, which tells me 0. Okay, my multiplier is plus 10 to the 0. Okay, and then my gold band at the very bottom tells me that it's a plus or minus 5%. So my resistor is going to be 10 times 10 to the 0 power plus or minus 5%. Okay, this calculator will help you identify the value, tolerance, and temperature coefficient of a color-coded resistor by simply selecting the band colors. It will also calculate the minimum and maximum values based on the tolerance ratio. Okay, this calculator supports resistors with 3, 4, 5, and 6 bands. So how do I use the calculator? Select the number of bands in the resistor that you're trying to identify. For each band, select the color matching in the table column, indicating the band number. The resistance value will be calculated and shown with the minimum and maximum values. Okay. That is the explanation of this band right here. Okay. This resistance would be 10 K ohms plus 5%. I forgot to say that at the very end. Okay, so this tells me that I have three large ones, one smaller one that would be black, and then I've got my gold band on the bottom. Okay, now, do we have any questions so far? Because I know that this can be a confusing set of things to do. So if you have any questions, please post them. I'm going to give you just a minute to write your comment and then hit it. Okay, we're going to move along. Okay, is a 3-terminal value resistor that is used to adjust the voltage and current in a circuit. That's a potentiometer. Okay, the arrow represents where the output voltage is taken from, and the 2 terminals are V plus and ground. Okay, so we will find a few potentiometers in a oven circuit depending on the manufacturer brand. Okay, so you need to have this information with you, because if you don't, you're not gonna you won't be able to do it right. Okay, so this right here is a 5-volt battery. You can see the positive and the negative. Okay, you can see that I get a 1K ohm resistor. I have 2 1K ohm resistors. Okay, so I've got I read 2.5 volts. Okay, so exactly what does a capacitor do? A capacitor actually stores electricity. Okay, so one of the things that you need to know is I need to have a bleed circuit on this capacitor, and I'm still not going to guarantee that I might not get shot if I don't discharge that capacitor. Okay, there are capacitors in your oven board. If you go and you pull an oven board and you look at the schematic, you're going to see probably in excess of 5 or 6 capacitors, especially if it's a double oven. Okay, so if I have a non-polarized capacitor, it's the symbol that's on the bottom left. Okay, it has no polarity, so it doesn't matter where it's placed, negative or positive side. They usually have a smaller value. That's the symbol right there. Okay, if it is a polarized, capacitor in the circuit, okay, polarized does matter which way is put into this whenever you put it back in. Okay, they are connected to. They usually have a higher capacitance than a non-polarized counterpart. And if you look at look at it right there, you can tell there is a plus, and that tells me that my plus symbol, the plus on the capacitor has to be in the plus position. Otherwise, it will not work. Okay. Now we're going to talk about diodes. Diodes have become very popular in an oven. Whenever I first started, they were not quite as popular as they are today. Okay. A diode, the thing about diodes that everybody loves is it's a polarized device that allows current only one way. Okay. It will not allow, if I were to flip this diagram upside down, that diode will not work. Okay. I have to have a positive and a negative Okay. The positive portion of it is the anode, and the negative portion is a cathode. Okay. The flat edge on the triangle is the anode side. Okay. So if you look at the triangle, there's a line right above it. Okay. That tells me right there that it is positive on that side. My negative or cathode side is the one on the bottom. Okay. So the cathode, we've gone through those. Okay. So if we look right here, okay, and this symbol right here, I have 1, 2, 3 resistors in line. Okay. I'm told that this is a 5K ohm resistor. The one below it is a 5K ohm resistor. The one below that is a 2.5K ohm resistor. So if I'm looking at resistance between this whole circuit, I should have a total of 5, 10, 12.5 K ohms. Okay. Now we're going to talk about inductors. Okay. Inductors are a passive component that create a magnetic field when current flows through them. So a good example of an inductor, if you think about a transformer, it has two sides. One is a low side, one is a high side. Okay. And as the current flows through them, it increases. Okay. Transformers voltage by stepping up the voltage. If you look right here, this is what I was talking about. So the transformer transforms voltage by stepping up the voltage either up or down. They are made up of two wires or coils wrapped around an iron core. The symbol reflects with two wires on each side with the iron core in the center. So if you think about your oven, it has a transformer in it, at least one. If I have an upper and lower oven, I have two transformers. Okay, because they both do this. They're both operating a different portion. I'm operating either an upper oven or a lower oven, so I have two transformers. Okay, so if you think about a microwave, of course there's a symbol for the microwave. How do I know which wire is the low side and which wire is the high side? The low side is always the thicker wire. The high side is a thinner wire. Okay. This is an example right here of an oven. Okay. As you can see right here, there is the transformer that's down there on the very bottom that we talked about. As you can tell, that this is a microwave. I thought that I had it as a oven, but I was incorrect. But same thing. I mean, it's all the same. So if you look one there, that's the transformer. And then if you look at the top, there's an inductor up there at the top. Okay. Now let's talk about relays. Okay. Relays are electronically operated switches that basically electromagnetic uses open and closes when the current is applied to the coil. So that coil gets energized. Whenever that coil gets energized, that's whenever it closes that switch. That's how that switch becomes closed, is because of the energizing of the coil. Okay. Everybody's, speakers, those used to be almost non-existent. That now they're in everything from washers to dryers to ranges to ovens to it's on everything that we have almost now. All right. So can you identify the parts? If you look right here, there's the transformer. Shows right there the transformer. Then a single pole, single throw switch is right there. Okay. If you look, this is actually an oven. You can see right there that it has a door lock motor. Okay. Once it energized, once the door lock is closed and it's switched on, it actually has the symbol for this one is a little bit different, but it actually the electromagnetic force closes that switch, which actually goes to the from the door lock switch, and it goes through and turns the oven on for the self-clean cycle. Okay. If my indicator light, when it's was out on the diagram, which points would I check for power? Okay. So the answer is I would use 3 and a neutral. So I go to my wiring schematic. I've traced the wires. I see that this is my power wire, and then my neutral is over here on the right side. So I would go between these to get my voltage. Okay. So this right here is a gas oven. Okay. So if I look at the doors, the door switch and the momentary switch is right here on the bottom. Okay. What pins would I use to check the meat probe for power? If I come over here, it's pretty simple. Like I said, you have to go through 1 to 8. So it tells me that I would go from point 1 to a neutral or a ground. Okay. Which is the common. So it would be between 1 and 2. Okay. With a quick look in this oven, is it gas or electric? Right here, it tells me that I have igniters. So if I have igniters, that tells me that I have a gas oven. If my oven light wouldn't work, what switches need to be closed for this oven light to work? If you look right here, there's an oven lamp indicator switch that's got to be closed. I've also got to have a normally a closed. The other side of the switch is for the door switch. Okay. If the door switch is this door switch a momentary switch? If you look at this one right here, okay, as we gone through, this is definitely a momentary switch. Okay. So let's talk about checking the elements on a range. Now we're going to get down into the meat and potatoes of what we just learned. I hope that you have had that was a good experience for you about reading schematics. Does anybody have any questions before we get into the meat and potatoes? Most of the things that we're going to deal with are electric ovens. A gas oven is just as easy to work on as an electric oven, but we're going to deal probably mostly with the elements on an electric range. Okay, so if I have no heat, okay, the first thing I'm going to do is I'm going to check the fuse just to make sure that I have 220 volts. Then I'm going to if that's tripped, I'm going to reset the breaker. Okay. But that doesn't solve things, because this is usually on the only thing on the circuit. Okay. So if it's the only thing on the circuit, I need to figure out why the breaker blew. Okay. So I'm going to have to go back to the oven. I can, if it's a single oven, I'm in a whole lot better place, because a single oven weighs about 145 pounds. And depending on the manufacturer, a double oven can weigh, anywhere from about 200 pounds to 250 pounds up to probably 400 pounds. Whenever I work for Viking, Their Viking double ovens, I think, were 380 pounds. Okay, so to check the bake or the broil element, I'm going to set my multimeter to the lowest ohm setting, or I can reuse the resistance sound mode. I can use either one. Okay, if your bake or broil element reads between 30 and 100 ohms, if it's what I should be getting, if you look right here, I've got 46.3 ohms. That's telling me that my element is good. If I don't have something in that range, I'm going to have to replace that element. I will tell you that if I am a technician, if I have a bake element that's bad or a broil element that's bad, I'm going to look at the bake element and the broil element just to see if I can look at it and tell me, hey, it's bad. You can look at it usually, and there's stuff that has splattered on it, and it has caused the element to go bad. Okay, so if I'm going to check my bake or my broil element, all I have to do is remove the two connectors, and I can ohm out my bake and my broil elements. Number one, I do this with the oven unplugged. Please do not try to not do it with the oven either plugged in or the switch in the on position. Please, you will fry yourself. Okay. Notice the bake and the broil elements in this one. This is off of a Whirlpool oven that has a hidden bake element. Okay, it's pretty easy to check the broil element in it. I can go to it right there. The bake element, if I have to replace my bake element, depending on the model number of the oven, if I have a hidden bake element, depends on the model number of the oven. I could be able to pull it out from the front, or I have to pull it out from the back. So that means that I have to pull the oven all the way out. So if I have an oven and it's a double oven and I have 300 pounds, I have one of two ways to get it out that is suitable for a technician. I can bring an extra man. We can bring it out and set it on the floor or set it on a toolbox. I can set it on something so that it never comes in contact with the floor, or that's with an extra man, or I have to have an oven dolly. Okay. I found a guy with an oven dolly that he was only wanting $50 for it because he was getting out of the business. It was in good shape. I told him that I would be there. Before I got there, he called me and said, "Hey, listen, the guy came by and got it. I've already sold it. I had somebody else that was interested." So if you can find one, that's not a cheap item. But if you can find one, that's the best way for you to pull an oven. Okay. So this gives you exposure to the element. Here's an example. Okay. This is a Whirlpool oven that has this hidden bake element. As you can tell, it's got a little bit of rust kind of underneath because it is the hidden bake element. Nobody ever cleans it. I will tell you this. It is highly unrecommended. As a matter of fact, if you have a customer and they put tinfoil down on the bottom of the oven, that will cause the element to short out a whole lot faster. Not only that, it can cause issues with the customer. They could get hurt. I always tell people if you're gonna put something down as a mat, they make a new mat that you can just slide up under it. That is not metal. Okay. So please have your customer go ahead and spend that extra $10 and get one of those. Okay. So I'm going to lift the element up so that you can get to the wires through the cavity oven door. This is how I can check this element. I'm going to disconnect the wires to ensure that they don't slip through the back of the cabinet. Be sure that the terminals are ready to reinstall on the new element, and don't show signs of arcing or thin insulation. If I have arcing or thin insulation, I am going to have to probably pull that oven out of the wall. There's nothing worse whenever my day, if I ran into an oven and this happened to me, I knew the rest of my day was going to be terrible. Okay. And that's if I go and I'm getting in a hurry, and I have had it where I went and took the screws out, and as soon as I went to pull it, the wire came off and it went to the back of the oven, and now I have to pull the whole oven out. That just added 20 minutes to 30 minutes to my time to do it. So please make sure that whenever I'm pulling this out, that I can hold that wire. I actually used to have a couple of little clips that I would pull it out, because you could pull it out just enough to use this clip to clip on, and it wouldn't allow it to come back. It wouldn't allow that wire to go back into the oven cavity. Okay. So I'm going to disconnect that wire. I'm going to check them. I'm going to make sure that I have no signs of arcing, or that the insulation has turned black. If I have an insulation problem that it has turned black, I'm going to have to splice that wire. I have to use a special wire. I just cannot show up and go to my truck and grab me a piece of wire off of something else and use it. It has to be made for an oven. Okay. Some of the ovens, depending on how old it is, the oven in my home in Daytona is so old that it actually has two screws. And whenever I get ready to replace the element, which I've already had to do, thank goodness I had my clips that I could clamp down on that wire and then unscrew it, and it didn't go back into the element, back into the back cavity. Okay, so I'm going to replace those. I'm going to do the opposite of what we just did. Okay, and then after installation, I'll turn on the breaker and I'm going to test it if I think that, to make sure that I have the exact problem taken care of. Okay, to remove the broil element, there are 4 screws. Okay, that you have to remove. You can tell that there are 2 of them right there. The other 2 are on the very back, and they're right there. So once I remove those two screws in the front and the 2 screws in the back, that element will hinge down. I have to be very careful for the same reason as I pull through the cavity. Otherwise, my thing may pop off and I lose my wire, and then I have to pull the oven again. Okay, so I'm going to pull it forward slowly. I'm going to make sure that I check the wires, make sure that they're good. Once I check those wires, I'm going to take and replace my element. The one thing that I will tell you is some of the elements that you are getting, you have to remove the support bracket. If you look right there, that's the picture of the support bracket. Okay. Sometimes I don't need it. I can just throw it with the element, but I have to make sure that I've got it, because I have walked into a customer's home. The guy behind me didn't replace the support bracket, and now it's hanging down about this far, and that's not good either. Okay. So This is the only thing that I'm showing you about a gas oven. Okay, 9 times out of 10, you have a problem. Your problem is your igniter. I have run into the other problem that I'm going to tell you about. Like I said, 9 out of 10 times, I'm talking about the igniter that's going to be bad. The other thing that could be possibly bad could be the gas valve itself. Okay, so let's talk about the igniter. Okay, it's 120 volt. It goes to the oven control. From the oven control, it goes to the igniter. From the igniter, it goes to the safety valve. Okay. Once again, this is the way that it looks on your wiring schematic instead of your drop down. Okay. So let's go back to this. So what will happen is my glow bar will glow. If I don't get a glow, I'm going to look at the glow bar itself. Usually I can just take one screw off and look at the glow bar itself, see if it, and I'm going to find out 99 times out of 100 that the glow bar is bad. And I can physically see that the glow bar is bad because there'll be a piece missing out of it or it'll be melted. But sometimes you're not going to find it. I found on several occasions whenever I was working on an oven that the glow bar just didn't reach the correct amperage. Okay. If I'm looking at a very old oven, it's usually about 3 to 3.3 ohms. If I'm looking at one of the newer ovens, it can be somewhere from 3 up to about almost 4.5. Okay. I think it's 4.2. So I'm gonna look. It's never gonna be too much. It'll only be too little. So if I don't get at least 3 ohms, I'm gonna have to replace that igniter. I used to always carry igniters in my truck for every manufacturer because if we were a heavily gas area. And I prefer gas over electric, but most people love electric. Okay. So in the very beginning, we actually sat and talked about our high limit switch. Okay. So on the back of an oven, there's a high limit. Okay. That high limit is set to go off somewhere between 1,000 and 1,500 degrees. Okay. Whenever I put my oven into a self clean cycle, depending on the oven that I get, either if it's a Whirlpool or a KitchenAid or one of the other manufacturers, it'll show me. Okay. Later on, once I get through this, I'm going to tell you that if something happens, you can kind of get a customer through, but we'll get to that in just a minute. Okay. So I have a high limit. So the first thing I'm going to do is I'm going to remove the oven from the cavity. I'm going to place it over a protected surface on the floor. I'm going to remove all the screws on the back of the oven. I'm going to grab my meter. I'm going to set it to the ohms scale. And then I'm going to remove one of the wires and I'm going to check for continuity. If I don't have any continuity, I'm going to have to replace the fuse. That tells me that the oven has gotten too hot and it has gone off on this high limit. Okay. So this is the normal high limit, the one that's in the very center. Some of the newer high limits, if you look at them, they are right here. But that's what I've got. Okay. If the meter is reading 0, what does that tell you? Is the fuse good or bad? Okay. If the meter reading doesn't change or it doesn't go to zero, what does that tell you? If it doesn't change or it doesn't go to bad, what does that tell you? Okay. Oops, I'm sorry. That's the piece that I was looking for. This is for checking continuity through the gas valve that we talked about with our gas valve. So let me stop right here. I have had a technician, and he actually demonstrated this for me. Your high limit thermostat actually has a bevel inside it. And what happens is it gets so hot that it expands and it pops. It'll actually, usually you can hear it pop. Okay. So what can I do if I'm trying to get this customer just with a temporary fix? Usually I can either this guy took and tapped it with a hammer and got it to unflex. I have heard of people that took and dropped it on a concrete floor, like in the garage, dropped it on the floor and got it to reconnect. That's a temporary fix. But that's as we get into where we are right now. Next Thursday's Thanksgiving. When there's nothing more than a panicked customer, and you get out there and it's a high limit because everybody's cleaning their ovens and they're running their unit into a clean cycle, and then they have the problem with it not working. So sometimes you can get that. If I don't have one on my truck and I can get this customer through, I'm going to try anything that I can to at least get this customer through. Okay. And usually, like I said, it's because the customer has put this into a self-clean. That's going to be one of my questions is, what were you using? Have you used the self-clean mode? If they tell me no, I have not used my self-clean mode at all, then I'm going to have to look for an airflow issue. Okay. Does anybody have any questions now? Okay. So, like I said before, we were talking about gas valves. Okay. There was only two slides for gas ovens. So I've got to check my continuity through the valve. If I don't have any continuity, what happens is my gas valve is waiting for my igniter to tell it, okay, I'm ready to release the gas. Go ahead and release the gas. If my continuity through my valve is bad, I'm not ever going to release the gas. So that's the reason I have to check my amp with my amp probe, the amperage that I get through my igniter. Okay. My gas valve, I can check it just with a ohm meter and run and check it on the lowest ohm scale. Okay. So that winds up our gas. But here's a thing. This is actually, the meter is set to a tone, and that's all really I have to do to check that valve. Okay. So I'm going to place my lead on the terminal. Place the other lead on the other terminal. So I have to pull the wires off of both terminals. Otherwise, I can't effectively say that it's definitely good or bad. Okay. If the valve shows a resistance of 0 up to 0.5 ohms, the valve is good. Okay. All right. Does anybody have any questions? Okay. I don't see any questions, so we're going to stop and we're going to talk a little bit about the Easy Stock app. Okay. Many of the times I have told everybody, uh, if I'm a technician, I am going to have the Easy Stock app on my phone. Okay. Right here, my phone with the Easy Stock app on it. Well, maybe. Okay. So, what do I need to be able to use Easy Stock? Okay. The first screen tells me that I need an account and a passcode. Okay. So, how do I get an account with Encompass? If I'm buying parts, you already have an account. Okay. I now put my account number in there. Then the next thing I do is I have to go and tell it, okay, if this is the first time I've ever done this, I have to assign a passcode to it. Okay. If I already have a passcode, or you're a technician with multiple technicians, and somebody else has it, you have to find their passcode, because with your account number, you can only have one. You can only have one passcode. So I'm going to type in my account number. I'm going to type in my password. Once I type in my password, it'll bring us up to another screen. Once I bring it up to my screen, it'll ask me. It actually asks me what I want to do, and I do that by just clicking on it. And I can go in and I can search for parts. I can check and see if I have any truck stock that on one of the other trucks. If I have a warehouse that I stock parts at, I can check my truck stock on at the parts. Like I said, if I don't have any truck stock and don't have it anywhere else, I can actually have it order parts whenever I reach a certain stock level. So let's say that I have a fast moving part. It's something that I replace probably every day. What am I going to do? I'm going to go to the Easy Stock app. I'm going to tell the Easy Stock app, listen, if I get down below 2 of these, as soon as I reach the 2 mark of that I have in stock, I want to order 2 more. At that point, it will actually go and order from Encompass and use my account number. As long as I have my credit information stored in it, it'll go ahead and order it for me. Okay. How do I know what's a fast moving part? One thing about the Easy Stock app, I can go down and I can find my fast moving parts by running what kind of usage I have had for those parts over the last however many days you put in it. Whenever I was a manager, I always had that was what we lived and breathed by. I couldn't have a technician going out 2 and 3 times because of the part. Okay, so our objective was to have first time completes. I had to have a certain level of first time completes. If I didn't, then I had to bring the technician in, and the technician and I had to have a discussion. And I would usually end up riding with the technician for a couple of days to see if I could help him with his parts issues. Okay. Because you don't make any money if I have to go out 2 times. Everybody knows that for me to run my truck back in the around 1999 up to about 2004, my cost for me to run the call was $58.63. That figured everything in. That figured gas. That figured in the technician's rate. That figured in the mileage on the truck. That figured in the oil, the gas, all of that. That was a fully loaded. It was $56 and 30 something cents. So that's what for me to make any money, that cost me $56 every time I rolls the truck. It was $56. Okay. So this will help me by letting me know if I'm getting low on certain parts that are fast moving, or if I need to start stocking that part on that truck because it has turned to a fast moving part. That app with Easy Stock will allow me to do that. So that's one of the things that I love about Easy Stock. Okay. The other thing that I can do, like I said, I can run a list for my top however many parts I want to put in. We had vans, so I had space in my van for about 300 parts. Okay. We basically ran Whirlpool or a Whirlpool derivative, which could be, it could be anything from a Whirlpool, a Roper, a Maytag, an Amana, any of those Whirlpool brands. Okay. And we ran GE heavily. So we had Whirlpool, GE, and we at one time we started with Samsung, and thank God we actually moved away from Samsung just because I had problems. They were rejecting claims for silly reasons, but that was a different issue. So this app will tell me what parts I need to put on my truck if I use it correctly. So I can use this. I can order parts. If I'm at the customer's house, and I'm going to give you an example. I used to have some of the parts shipped to a customer's house. If I personally knew the customer and knew they weren't going to try to, get out from under it and call somebody else, I would ship a part to their house. I would have them call me whenever they got that part. I would schedule for the next day, and then I would have them come back. So, that there are all kinds of ways to run your business, but this Easy Stock app makes it so much easier for me to run my business and run it effectively. Okay. Does anybody have any questions? Okay. Well, we have a class on Tuesday and we have a class on Wednesday. So we will not do Thursday because it's Thanksgiving. And I don't know about you, but like I said, I'll be eating some turkey, some smoked turkey, and all the fixings, as my grandfather says. Have a great day. If you need anything, my information is scrolling across the bottom of the screen. Reggie Williams's information is scrolling across the bottom of the screen. Okay. If you don't have Easy Stock, the Easy Stock app, you can get it in the App Store, or I can get it in the Google Play Store. One of the other things is, if I want to get a little bit better understanding of Easy Stock, I can actually go to YouTube. Whenever I go to YouTube, I click on Easy Stock. I'm gonna do it myself. Okay. Okay, Easy Stock app. Okay. So if I look at this Easy Stock for app for beginners, I pull this up, and what happens? I get 450 different things, and it has nothing to do with the Easy Stock app that I'm talking about. So I cannot go in and type in Easy Stop app for beginners. Okay. What I have to put in is Encompass. Okay. Encompass Easy Stock app. And that brings up 5. There are 5 videos out here. Okay. For the Easy Stock app. Okay. That's where I'm going to go. I can click on that Easy Stock app, and there are several short ones, and then there are several that are almost an hour long. Okay. So use Encompass. Okay. You're already using Encompass for their free classes. Use Encompass to help you with your business. Okay. Everybody have a great day. If you don't make it to either one of the classes next week, have a happy Thanksgiving. Be safe out there. Be careful if you're traveling with your family. Have a great day, and we will see you on Tuesday